Hello and welcome to the Logos Research Associates live stream broadcast. I'm John Baumgardner, and it is my privilege to be your host for this presentation. Logos Research Associates is a fellowship of scholars and scientists that are committed to upholding a high view of science and a high view of Scripture. We sincerely believe that scholarship, logic, and the scientific method can and should be used to show that the Bible's historical claims are both credible and ultimately superior to the secular model of origins. Logos sponsors many creation research initiatives and projects involving many different experts and scientific disciplines, all working toward the goal of increasing the explanatory power of the creation model of origins and of Earth history. The goal of this live stream series is to provide you with the opportunity to hear from top researchers who will convey cutting-edge scientific evidence for the creation account. Before I introduce our speaker to begin our presentation tonight, we will open with a short prayer. If you would please join me. Heavenly Father, we honor you, we glorify you for the creation that you have brought into existence. Psalm 33:6 says that by the word of the Lord the heavens were made, and by the breath of his mouth all their host. The God, you simply spoke and brought the universe into existence. It's hard for us to even imagine that kind of power. But as we look into the heavens, we're dazzled by that evidence that happened. Father, we thank you for this presentation tonight by someone who has invested many years of his life in training in astrophysics, and we're eager to hear his what he shares tonight. So now I have the privilege of introducing him. Our speaker is Dr. Markus Blietz from Germany. He was born in 1962 and has two children. They live in the shadow of the Alps, south of Munich. After studying general physics at the Technical University of Munich, he completed his doctorate at the Max Planck Institute for Extraterrestrial Physics in Garching, near Munich. Today, he works as a patent manager in the semiconductor industry there in Germany. It was in 2008 that he came to a living faith in Jesus Christ. And not long after that, he was moved by God to begin lecturing on the subject of the Bible and science. And so he's continued to do that over the last roughly 14 years. And he's among his talks is the one he's going to present tonight. The title is "Are We Facing a Climate Collapse?" And just in brief, he addresses the issue of, is the Earth's climate on the brink of collapse, and is mankind the cause? What is the scientific evidence? Is this really our biggest problem? What catastrophe truly threatens humanity? So at this point, I want to welcome Dr. Blietz to our live stream broadcast. Markus?
Yeah, thank you, John, for introducing me. I think I have nothing to add concerning my own person. But before we start with the presentation, I need to clarify that we have recorded this presentation because of the technical problems we had last time, so that we hope that this time it will be a smooth presentation and everybody can follow, and we can have a discussion afterwards. So I hope this will go well for everybody. And
yes, I might add that during the presentation, you're invited to type your questions into the chat box And at the end, we hope to have a vigorous conversation, a vigorous Q&A over points that have come to your mind as you've heard Markus speak.
Mm-hmm. Yeah, okay, yes. I'm looking forward to this. Yeah, I think from my point, I have nothing to add, and let's start with the presentation. Hello, everybody. I would like to welcome you again to my talk, Are We Facing a Climate Collapse? The talk has different parts. First of all, do we have a planetary emergency? Then, are extreme weather events increasing? How warm was it in the past? Has the rise in temperature been understood? Is carbon dioxide harmful? Climate politics? Is Gaia, Mother Earth, in danger? The biblical perspective? And what catastrophe is really looming? Do we have a planetary emergency? Al Gore, former US Vice President, has said, I want to testify today about what I believe is a planetary emergency, a crisis that threatens the survival of our civilization and the habitability of the Earth. Humanity is sitting on a time bomb. If the vast majority of the world scientists are right, we have just 10 years to avert a major catastrophe that could send our entire planet's climate system into a tailspin of epic destruction. Involving extreme weather, floods, droughts, epidemics, and killer heat waves beyond anything we have ever experienced. A catastrophe of our own making. And Barack Obama, former US president, increasingly dangerous weather patterns and devastating storms are abruptly putting an end to the long-running debate over whether or not climate change is real. Not only is it real, it's here, the man-made natural disaster. So the politicians are quite clear about this. But what are they talking about? First of all, they talk about hurricanes. Hurricanes typically travel at speeds of 50 kilometers per hour. Wind speeds range from typically 100 to 250 kilometers per hour, with a maximum of 300 kilometers per hour having been measured. They range in size from 100 to a maximum of approximately 2,000 kilometers in diameter. They occur in the tropics, that means to the left and right of the equator, and they are caused by warm, humid air rising at the equator. They typically live for a few weeks only. When they come ashore, they quickly come to a standstill, typically in a day or maximum of 3 days. In the Atlantic and Northern Pacific, by the way, they are called hurricanes. In the Southern Pacific and Indian Ocean, they are called cyclones. Hurricanes cause hardly any damage as long as they are still in the open sea. But they cause flooding when they make landfall. And the floods have particularly devastating effects where poor people live, like here in Haiti. And wooden houses are often particularly badly affected, especially in US. In Germany, it wouldn't be so bad because we have mainly stone houses. Another thing the politicians are talking about are tornadoes. Tornadoes typically travel at speeds of 50 kilometers per hour to a maximum of approximately 100 kilometers per hour. Wind speeds range from 50 to 500 kilometers per hour. They range in size from a few meters to about 3 kilometers max in diameter. They mainly occur in mid-latitudes, and they are caused by the collision of warm and cold air currents that occur on large continents. They typically last between 10 minutes and 1 hour. Tornadoes can easily lift a school bus, as can be seen here. And when they sweep through small American towns, they often leave a trail of destruction in their wake. Another catastrophe often invoked by politicians is drought. Without water, there is no life. And shipping also comes to a standstill. Devastating droughts occur particularly frequently in regions that are already climatically disadvantaged. The next point I want to talk about are extreme weather events increasing. Al Gore announced his inconvenient truth in 2006, where he warned of an impending climate catastrophe. But is it justified to talk about an impending climate catastrophe? What does the measurement data look like, and what is climate anyway? Climate is generally understood to be the 30-year statistical average of weather elements such as temperature, wind speed, and precipitation. Climate should not be confused with the weather over shorter periods of time. It's the weather we are talking often about, but climate we cannot really, in our head, make a statistical average of 30 years, right? There is also no global climate, only climate zones from polar to tropical. Each climate zone has its own climate. Like can be seen here, we have different climate zones. In white, the ice climate. In light blue, the tundra climate. In purple, the boreal climate. In green, the warm temperate climate. In yellow, the subtropical climate. And in pink, the tropical climate. The northern and southern hemispheres also behave differently. The southern hemisphere and Antarctica in particular is warming much more slowly than the northern hemisphere. The data shown below, which I will show soon, is limited to the northern hemisphere, where more than 85% of the world's population lives. The data show large-scale and long-term trends without going into specific regional differences. The first graph I am showing here is the number of all US hurricanes, the number of US hurricanes per year between about 1850 to up to today. You can also see a link where you also can load the data if you want and plot your own, so it's not a secret. In blue is the actual data, and I've also drawn a fit curve, a line, a red line. And I think it can easily be seen that there's a large scatter in the data, and especially that there is no significant trend in the mean value. Well, maybe the strength of all US hurricanes is increasing, and we see here the relative strength of all US hurricanes. Strength 0 corresponds to wind speeds less than 100 km per hour. Strength 1, 100 to 150 kilometers. Strength 2, 150 to 175. Strength 3, 175 to 200. Strength 4, 200 to 250. And strength 5, greater than 250 kilometers per hour wind speed. And again, I think you can clearly see by the naked eye that there is no significant trend in the mean value. Professor Roger Pielke, US environmental researcher, says hurricanes reaching the West Coast have not increased in frequency, strength, or damage since at least 1900. This has also been true for tropical cyclones since at least 1970. Let's look at strong US tornadoes. Strong tornadoes are tornadoes with wind speeds of over 220 kilometers per hour that can destroy houses. And what we can see here clearly is the number of strong US tornadoes is decreasing. We have a falling trend of the mean value. How about the medium strength US tornadoes? They have wind speeds of 140 to 220 kilometers per hour, and they can still uncover roofs. Well, you can see here the data, and you can see the fit line. And I have applied a t-test with 95% confidence, and this is still not statistically significant. So no significant trend in the mean value here also. Professor Roger Pielke says US tornadoes have not increased in frequency, strength, or damage since 1950, and there are indications that they have even decreased, which I have shown to you. How about droughts? We have here the PDSI index, the Palmer Drought Severity Index. Negative indices indicate dryness, positive indices wetness. And again, I think you can clearly see that there's no significant trend in the mean value. No catastrophe is looming. Roger Pielke says, in the last century, US droughts were predominantly shorter in duration. So he has looked at other data where you can even make this less dramatic, less frequent, and covered a smaller area. Globally, too, there has been little change in the last 60 years. So what is my summary here? The summary is no signs of a climate catastrophe are recognizable from the data shown. Let's go to the next point. How warm was it in the past? Do we have temperatures that are worryingly higher than in the climate history of the last 2,000 years? How constant was the temperature in the past? We see here the green curve generated by the IPCC, or Intergovernmental Panel on Climate Change. It looks like a field hockey stick from the side, with an almost constant temperature curve in the past and a strongly increased temperature in modern times. The brown curve is connected to the green curve and shows direct measurements of the temperature since the middle of the last century. Here we see another blue curve. This curve shows the temperature curve according to Professor Bündgen. This curve shows strong temperature fluctuations over the last 2,000 years. The temperature in modern times is only slightly higher than this curve. This is Professor Bündgen's publication. Swiss, German, English, Czech, Canadian, Russian, Swedish, and US scientists were involved. Here we see a comparison of the IPCC and Professor Bündgen's curves. You can clearly see that Professor Bündgen's curve shows strong temperature fluctuations that are not visible in the IPCC curve. Even if we add the uncertainty in their curve stated by the IPCC, the temperature curve is still far too constant. This uncertainty is represented by the two light green curves, which form a band between which the dark green curve lies. The fluctuation in Professor Bündgen's blue curve extend far beyond even this light green band. What is the reason for this? Where does the discrepancy come from? Professor Bündgen says the inclusion of lower resolution proxy data with uncertainty in dating or systematic errors can lead to a virtually flat climate history. In other words, averaging over a lot of proxy data, these are data that allow indirect conclusions to be drawn about temperature, can lead to an approximately flat temperature curve, as in the case of the IPCC curve, with much smaller variations than actually occurred historically. You need high-resolution data with precise dating and without systematic errors to get the actual temperature curve and to recognize the actual fluctuations. Professor Bündgen distinguishes between different phases. The Roman warm period around 250 AD, the late antique Little Ice Age around 500 AD, the medieval warm period around 1000 AD, and the Little Ice Age around 1600 AD. And also shown here is our age. Professor Bündgen attributes a major role to volcanism. Volcanoes emit many suspended particles, so-called aerosols, which on the one hand directly block sunlight and on the other hand stimulate cloud formation. Bündgen explains the Little Ice Ages in the last 2,000 years as a result of temporarily increased volcanic activity. The warm periods were essentially recovery phases from the Little Ice Ages. Here the volcano Etna erupts with huge ash emissions. The mushroom cloud of ash reaches 15 kilometers high. This image is from December 2015. More confirmation for Professor Bündgen's curve comes from glaciers, for example, the Great Aletsch Glacier in the Alps. This is the largest and longest glacier in the Alps in terms of area, the Canton Valais in Switzerland. It has an area of around 82 square kilometers and a length of around 23 kilometers. We see here the development of the glacier, meaning the length of the glacier is measured. On the mountains, the black mountains you can see here, the glacier has expanded in length. In the valleys, it has retreated. The curve follows in first approximation the temperature curve, which we see superimposed here. The red areas show warm periods. The green areas, cold periods. During the warm periods, the glacier was retreated. During the ice ages, the glacier was advanced. Hannibal, who crossed the Alps with elephants in 218 BC, fits in well with this. He would not have been able to do this if the glacier had been extensive. Professor Schlüchter, a Swiss environmental geologist, says between 1,900 and 2,300 years ago, the glacier tongues were at least 300 meters higher than they are today. In Roman times, the glaciers were hardly experienced as such, for the simple reason that they were far away from the alpine crossings used at the time and were therefore not perceived as an obstacle. How great is the rise in temperature compared to fluctuations in the past? Rajendra Prakhauri, former chairman of the IPCC, says, warming of the climate system is unequivocal. Most of the global average warming over the past 50 years is very likely due to anthropogenic greenhouse gases increases. So in order to answer our question, we look at what he's saying, especially about the past 50 years, as he says. With keeping this in mind, we go back to our global temperature trend here. And we see here the global consumption of the fossil fuels, gas, oil, and coal. The golden mountain underlying the temperature curve you see here. This is the full, which shows the full consumption in billion tons per year. If, according to Rajendra Prakhauri's statement, we take 1957 as the lower measuring point, he spoke of 50 years in 2007, and follow the curve up to the present in 2024, we get a temperature rise of 1.3 degrees Celsius in 75 years. How does this compare with the fluctuations in Professor Bühnken's curve? The temperature rise in modern times of 1.3 degrees in 75 years is compared here with the fluctuations in the past. As an example, the temperature rise of 1.9 degrees Celsius in 56 years during the late antique Little Ice Age is used. This is obviously a much steeper increase. Another example is the temperature rise of 1.4 degrees in just 43 years during the medieval warm period. These temperature rises were significantly higher and faster than in the modern era, without human influence, of course. The recent temperatures are not worryingly higher than in the past. That's my summary. Also, the rise in temperature in modern times is not dramatically faster compared to the fluctuations in climate history over the last 2,000 years. I'm coming to the next point. Has the rise in temperature been understood? CO2 is produced during combustion processes. CO2 is a greenhouse gas and causes the greenhouse effect. The effect gets its name from a greenhouse. In our example, it's a glass greenhouse. Sunlight penetrates through the glass into the greenhouse and is absorbed by the plants. Some of the radiation is re-emitted by the plants as heat radiation. However, the heat radiation cannot pass through the glass. This warms up the air in the greenhouse, which is also desired by the greenhouse owner as the plants then grow better. The greenhouse effect in the atmosphere is similar. Of course, there is no glass in the atmosphere, but the CO2 in the atmosphere acts, so to speak, like a thin layer of glass. It does not allow all the heat radiation to escape into space, but retains some of it, which warms the Earth. Without the greenhouse effect, our planet would be very cold and inhospitable to life. Is the temperature increase now directly proportional to the amount of fossil fuels burnt by humans, or is it more complex? What factors need to be taken into account? One example of the complexity of the climate system is water vapor. Water vapor is a more effective greenhouse gas than CO2. It leads to a feedback effect by amplifying the temperature increase caused by CO2. This feedback effect is not linear or proportional to the amount of CO2 increase. 70% of the Earth's surface is covered with water. Our planet looks like a blue marble from space. So water vapor has a great effect on the climate system. Another example of feedback effects are clouds. Clouds can contribute to both warming and cooling. Warming can take place through the clouds as the heat radiation emitted by Earth is partly radiated back to the Earth. Cooling can occur when sunlight, before even reaching the Earth, is radiated back into space. The feedback effects make it difficult to predict the temperature trend. Professor William Hepper, US physicist, says, the effects caused by direct changes in greenhouse gas concentrations can be calculated quite accurately. The temperature changes caused by greenhouse gases are less clearly defined because various feedback effects change the temperature profile of the atmosphere. Climate models are created to determine the extent of human influence. The predictions of these models are then compared with the real measured values. If they agree, this indicates that the Earth's climate system has been understood. If they do not match, we still know too little. The average global surface temperature is shown here. It can be seen that the average of the climate models characterized by the red curve has deviated more and more from the blue curve, namely the observations in recent decades. And this means that the average of the models is overestimating the overall temperature rise of Earth's surface. This illustration, another curve, shows the global temperature of the lower troposphere, which is the part of the Earth's atmosphere that is important to us. In red is, again, the mean of the models. In blue, green, and black are the measured data or values. You can see again that the average of the models is overestimating the trend. Now I'm showing you a third curve. Here you can see again the temperatures in the Earth's lower atmosphere. The blue curve represents the satellite measurements. The many gray curves are, in German, Satellitenmessungen. The many gray curves are 41 individual IPCC models. You can clearly see that in the 1980s, the models still agreed with the measurements. In recent decades, almost no model has been able to reproduce the trend correctly. Most of the models are overestimating the trend. They are running too hot. Professor John Christie, US atmospheric scientist, says the models show a stronger warming than the observations in the lower and middle troposphere, in the tropics and globally. The discrepancies are very significant on average of the models, as well as for most individual models. My summary is as follows. The measured temperature trend is at the lower end of the models. This indicates that the models do not yet describe the temperature trend well enough and tend to overestimate the influence of humans overall. An imminent climate catastrophe cannot be deduced from the models. Let's go to the next point. Is carbon dioxide harmful? In view of the fact that carbon dioxide only gets negative headlines in the media, we want to ask ourselves more generally what role carbon dioxide plays in the atmosphere. Combustion processes in industry produce CO2. In addition to CO2, fine dust as well as sulfur and nitrogen oxides, SOx and NOx, can also be produced. Fine dust can lead to allergies and respiratory problems. Sulfur and nitrogen oxides can cause acid rain. In road traffic, on the other hand, combustion engines also produce CO2 again. In addition to fine dust and sulfur and nitrogen oxides, carbon monoxide, CO, can also be produced. Carbon monoxide can put a strain on the nervous system and the cardiovascular system. While it is a good thing if environmentally harmful gases are reduced in industry and road traffic by filter systems and so on, carbon dioxide is not an environmentally harmful gas. On the contrary, CO2 is vital for the photosynthesis of plants. Plants absorb CO2 from the air through their leaves and water through their roots, thereby building up their plant material. As a side effect, they produce oxygen, which we then breathe in again. Plants react very positively to an increased CO2 concentration. We can see this in this graph. Below, we see the CO2 concentration in the atmosphere in ppm. 1 ppm is 1/1,000,000th of the atmosphere. We see two curves, a blue and a red curve. The blue curve is for unstressed plants with normal growing conditions. The red curve applies to stressed plants with unfavorable growing conditions, for example, too hot, too cold, too dry, too moist, and so on. You can clearly see that the higher the CO2 content, the greater the increase in plant growth. In 1900, the CO2 content in the atmosphere was approximately 300 ppm. Today, in 2024, it is approximately 400 ppm. For the period from 1900 to today, the graph shows that the plant growth has increased by 20 to 30% worldwide. This means that the global production of plant-based food has also increased accordingly. CO2 was a free fertilizer from the air. Here you can also see the positive influence of CO2 on plants at 461 ppm, 782 ppm, and 1218 ppm. This is about 2 to 3 times the current value. The more CO2, the better. The owners of greenhouse tomatoes have known this for a long time because they gas the tomatoes with CO2. This makes them grow better. Plant growth has increased worldwide due to CO2. We can see this from satellite images from 1982 to 2015, which show here the percentage change of leaf area. White areas are deserts or ice regions where practically no vegetation grows. Brown patches indicate a decrease in plant material, such as in South America, where the tropical rainforest is being cut down in places. Otherwise, the global increase in leaf area in just 33 years can be seen very clearly. The increase in leaf area corresponds to twice the area of the USA. In fact, it's the single leaf area. In the tropics, one reckons with up to 7 leaf levels, as here the vegetation grows on different levels. Evolutionist scientists assume that 70% of this greening of the earth is caused by the increased CO2 concentration, less than 10% by the increased temperature, again caused by CO2, and the rest by other factors. For example, afforestation by humans only contributes around 4%. Professor Ranga Muneni, OS biologist who did these studies, says, "We were able to attribute the increasing greening largely to the fertilizing effect of increasing atmospheric CO2 concentration by commissioning several computer models to simulate the plant growth observed in the satellite data." As already mentioned, not only common plants grew more, but also plants that serve as food. This is particularly important for many countries in the developing world, where rice, for example, is the main foodstuff. The German researcher Susanne von Kemmerer has demonstrated in a publication that rice reacts very positively to CO2. It grows better with increasing CO2 concentration. The graph shows that doubling the CO2 concentration from 400 to 800 ppm has a very positive effect. There's only one thing you must not do. Don't give the rice too little CO2. It won't tolerate it. Note that it is sometimes claimed that rice grown at higher CO2 concentrations has fewer nutrients. This is true, but the effect is relatively small. For example, if CO2 doubles, that is, increases by 100%, then the nutrient content decreases by approximately 15% only. Overall, this results in an increase in nutrition of approximately 85%, which is still very strong. Professor Fred Decker, US meteorologist, says there is sound scientific evidence that an increase in the carbon dioxide content of the atmosphere has many positive effects on the natural environment of plants and animals on our planet. And Professor Freeman Dyson, US mathematician, the main reason why CO2 in the atmosphere is so critical for biology is that there is so little of it. A cornfield growing in the middle of the day consumes all the CO2 up to a height of 1 meter in about 5 minutes. If the air wasn't constantly moving, the grain would stop growing. So basically, we are in an almost CO2-starving world. I'm summarizing. CO2 is not an environmentally harmful gas like many other fuel products, as for example sulfur oxides and nitrogen oxides, which lead to acid rain. CO2 is vital for the photosynthesis of plants. An increase in CO2 concentration leads to increased plant growth. It is therefore also used for gassing in greenhouses. Plant growth has increased considerably worldwide due to the rise in atmospheric CO2, which has led to a significant increase in food production, particularly in third world countries. Now we are coming to climate politics. Climate politics aims to limit global warming by reducing global CO2 emissions. The Paris Agreement, concluded in 2015, is currently in force. As Germany's contribution to global CO2 emissions is very small, even in the best case scenario, Germany makes practically no contribution to limiting global warming. As an example, we calculate the effect of the 40% reduction in CO2 emissions by 2030 agreed by the EU and the German government in 2014. The global CO2 concentration in 2014 was around 400 ppm. Assuming annual growth of around 2 ppm, this results in an increase of around 30 ppm by 2030. As the German contribution to global CO2 emissions is around 3%, it's not more, this results in a German share of around 0.9 ppm. According to the German government, 40% of this is to be reduced. That means around 0.4 ppm. The global temperature increase per 1 ppm CO2 is, and you can look this up in any IPCC report, is around 0.01 degrees Celsius. This means that the German reduction of 0.4 ppm corresponds to a global temperature reduction of only 0.01 times 0.4 equals 0.004 degrees Celsius, which is basically negligible. The situation is somewhat different when you look at countries such as China, the USA, India, and Russia, which emit the most CO2. If these countries were to significantly reduce their CO2 emissions, this would in principle at least have a measurable effect. However, such a reduction is accompanied by considerable costs. For this reason, the Paris Agreement is proving unsuccessful. According to a study from 2021, the previous targets cannot be achieved unless efforts are more than doubled, which is not on the cards. By reducing CO2 emissions, politicians are officially pursuing the goal of limiting economic damage and guaranteeing global security. The economic damage that is feared as a result of further warming includes, for example, increasing flooding and extreme weather situations that could affect buildings and infrastructure, agriculture, and tourism. Political security concerns include the impact on food, water, and energy supplies, increased competition for natural resources, climate-related disaster, forced migration, and displacement. Angela Merkel, former German federal chancellor, said, "Climate change is accelerating. It threatens our well-being, our security, and our economic development." And Kofi Annan, former UN Secretary General, "Global warming must be seen as an economic and security threat." The unofficial goal of politics, on the other hand, is to use climate change as a vehicle for establishing a world government. Jacques Chirac, former French president, has said, "The Kyoto Protocol is the first component of an authentic global government." The Kyoto Protocol was the forerunner of the Paris Agreement. For the first time in its history, humanity is installing a genuine instrument of global governance. There you have it. And Michael Gorbachev, former Soviet president, continues, the emerging environmentalization of our civilization and the need for vigorous action in the interest of the entire global community will inevitably have multiple political consequences. Perhaps the most important of them will be a gradual change in the status of the United Nations. Inevitably, it must assume some aspects of a world government. With their climate politics, which has been pursued very aggressively for decades, politicians have left a large part of the world's population with the impression that humanity is heading for a climate catastrophe. As a result, more and more people see saving Mother Earth as one of the most urgent problems facing humanity. For example, here demonstrators of the last generation in Berlin. This photo is from October 28th in 2023. Or here, forward on climate protests against the Keystone XL pipeline at Justin Herman Plaza in San Francisco. This photo is from February 18th, 2013. Or here, climate strike protest in Sydney, Australia. This photo is from September 18th, 2019. Many young people are here involved. But people are not only politically mobilized, a new world religion is also forming. Which brings me to the point, is Gaia in danger? Sir William Golding, English writer and Nobel Prize winner, says, we have seen our Earth, Mother Gaia, like a jewel in space. Now we have no excuse for considering her riches as inexhaustible and her habitat as unlimited. We are children of this great white blue jewel. Through our mother, we are part of the solar system and the entire universe. The entire range of living matter on Earth, from whales to viruses, from oaks to algae, could be considered as a single living organism capable of maintaining the Earth's atmosphere in a composition that suits its need. Our Earth, Mother Gaia, is seen as a superorganism that needs to be protected from exploitation and pollution. It is not man who is the highest form of life, but Mother Gaia. Mother Gaia is the origin of all life and deserves to be preserved and revered. The United Nations has also recognized this trend and is using a church center directly opposite the UN headquarters in New York, where the world's major religions are united under one roof: Christianity, Judaism, Islam, Buddhism, and Hinduism. The aim is to actively promote the unification of world religions in order to create a new green world religion. So green is basically the band which puts everything together. This is what the church center looks from the inside. In the background are the symbols of the major world religions: Christianity, Judaism, Islam, Hinduism, and Buddhism, only partly to be seen. The building was erected by the Methodists, who originally wanted to spread the Christian faith there. However, this place has long since become a site where the unification of all world religions is rehearsed. The chapel is the venue for ecumenical and multi-faith events and interfaith marriages. The same building houses the EOUN, the Ecumenical Office of the United Nations, the central contact point of the World Council of Churches for United Nations publicity initiatives. The entire building now bears the official name, the Church Center for the United Nations. Dr. Robert Mueller, former UN Vice President, has made some very important statements. He was the strategic most important person of the UN and has written a lot of books, very interesting. Here are some quotes from his books. My great personal dream is to form a powerful alliance between all religions and religious associations and the United Nations. We urgently need an organization of united religions to bring reconciliation, unity, and peace to all people on this earth. Al Gore, interesting what he says here, the climate crisis is not a political issue. It is a moral and spiritual challenge to humanity. It also gives us the opportunity to raise global awareness to a higher level. Robert Mueller. The root of the ecological crisis is a spiritual crisis. Just as the world's religions and spiritual traditions teach a respectful approach to a sacred whole, spiritual values and moral imperatives must help humanity develop a reverence for all life and for the sacredness of the entire planet Earth. Al Gore. The fate of humanity, as well as religions, depends on the future emergence of a new faith. It's about a new faith. Armed with such a faith, it may be possible for us to restore sanctity to the earth. Robert Muller. Step by step, a planetary prayer book is being created by an increasingly united humanity seeking its unity. Humanity seeks nothing less than its union with the divine, its transcendence into a higher form of life. Mikhail Gorbachev, the former Soviet president, said, "Do not do to the environment of others what you do not want to happen to your own environment." My hope is that the new Earth Charter, like the 10 Commandments, will become a Sermon on the Mount. And finally, he says, "Nature is my God. For me, nature is sacred. Trees are my temples and forests are my cathedrals." I think it couldn't be said more clearly. So the whole thing is a religion, and I will come to this in the last point. But before we do this, we sidestep to the biblical perspective. If we look at the global temperature trend from the perspective of the Bible, we come to a completely different conclusion than the majority of scientists who reject the Bible as the source of truth and instead proceed from evolutionist assumptions. The Bible tells us that there was a global flood catastrophe. The world before the flood was different from our world today. This is shown by the world's fossils. There is about 100 times more carbon in these fossils than in the entire biosphere today. This means that the world before the flood must have been filled with abundant plant and animal life. It probably looked like the tropics or subtropics all over the world today. Animals and plants were quickly buried then under sediment in the flood. And the fossilization or formation of fossils took place very quickly under the special physical and chemical conditions of the flood. In fact, evolutionist scientists found that the CO2 content in the atmosphere in the past must have been much higher than it is today. This led to lush plant growth worldwide, similar to that in the tropics today. Professor Creighton Yupp, US geologist, says, data from Goethite suggest that the atmospheric CO2 content was about 16 times higher than today. He refers to approximately 450 to 500 million years before our time, according to the evolutionists. In the biblical time scale, this corresponds to the beginning of the flood, when conditions in the atmosphere were most likely still comparable to the pre-flood world. We see here goethite, is also known as needle iron or brown glass head. It is an iron oxide and which contains carbonate. We see here the atmospheric CO2 concentration in ppm since 1850. The CO2 content in the atmosphere has risen by approximately 130 ppm in the last 170 years, not more. Here we see the CO2 concentration before the flood, which was 6,000 ppm higher than in modern times. The evolutionists would also have to place this measuring point at 6,000 ppm, even if they do not agree with the timescale. I have enlarged the minimal increase in modern times so that you can see how small it is. Many people are worried about this miniature increase, whereas the CO2 concentration in the past was already many times higher. If the CO2 concentration was so high back then, shouldn't the temperature on Earth have been dramatically higher? Creighton Yupp also determined the temperature back then, and he states, however, this increased CO2 content of the atmosphere does not appear to have been accompanied by unusually high temperatures in the tropics. God had created the world very well before the flood, and he set ideal living conditions for humans, animals, and plants. The high CO2 content of the atmosphere supported plant growth in particular, while the temperature in the tropics was similar to today. From a biblical perspective, the current increase in CO2 concentration is no reason to fear a climate catastrophe. Which brings me to the last point: what catastrophe is really looming? The view that the Earth's climate could be brought out of balance by humans is the result of evolutionary thinking. According to this view, our climate has supposedly stabilized to its current state over evolutionary periods of time through purely natural processes, but it is relatively susceptible to human intervention. In view of this, many people are seriously concerned, and a new green world religion is developing on our globe. So we can see here clearly that the worldview we have has a great impact on this world, especially on developing of new religions. In the German newspaper Welt, on 18th December 2023, one could read the following: the climate religion is filling the gap left by Christianity. The climate movement has many features of a religious community, with asceticism, atonement, and prohibitions. At the same time, the churches are losing importance. A historian explains the new form of indulgence trade and speaks of an eco-debt industry. This substitute religion has its own god, Mother Gaia, against whom you can sin if you damage the environment and the climate in particular. It also has its own 10 commandments. Remember what I quoted: do not do to the environment of others what you do not want to happen to your own environment. And it has its own high priests, the climate scientists, and its own prophets, political actors. Dr. Patrick Moore, Greenpeace co-founder, says the leading players in this religious war are people like Al Gore, Leonardo DiCaprio, and Greta Thunberg. Here Greta Thunberg with her school strike for the climate. These negative consequences could be avoided if we were to start from the Bible instead of evolutionary assumptions. According to this, our climate system is much more stable than the proponents of evolutionary theory assume. This is because the climate system did not develop by itself through natural processes, but was designed by God as a stable system. In Genesis 8:22, we can read, while the earth remaineth, seedtime and harvest, and cold and heat, and summer and winter, and day and night shall not cease. The stability of the climate system can be seen from the fact that in the world originally created by God, the CO2 concentration in the atmosphere was around 16 times higher than it is today, with ideal living conditions for humans, animals, and plants. The comparatively small increase in CO2 concentration in the last century is therefore no reason to fear a climate catastrophe. Because many people do not start from the Bible, they do not serve the God, but mammon. Mammon refers not only to money, but to everything in this world that is more important to people than God. In particular, it is their economic well-being and security. The consequence of this attitude to life is that people, consciously or unconsciously, serve nature and consider it to be holy and worthy of worship. But that is sin. For we humans should only worship the one true God and his Son, Jesus Christ. In Exodus 23, we can read, "You shalt have no other gods before me." God does not allow sin to go unpunished. And because he is holy and his moral standard is perfection, even a single sin results in eternal damnation. All people are therefore guilty before God and should be thrown into the lake of fire after their death. In order to escape this terrible eternal fate, God, who is not only a perfect judge, but also love, sent his Son Jesus Christ about 2,000 years ago. God became man in Jesus Christ and paid for the sin of mankind on the cross so that they would no longer have to be condemned. God now promises that every person who believes in Jesus Christ, who therefore trusts him and accepts him as Lord over his life, and thus no longer follows man-made worldviews and religions, will not be condemned. He receives eternal life. It follows that the greatest catastrophe that can befall a person is not a climate catastrophe, but the eternal punishment for rejecting God's Son, Jesus Christ. God created man in his image. This means that humans, unlike animals, have the opportunity to decide for or against Jesus Christ. God has determined this. Anyone who does not decide for his Son, Jesus Christ, has already decided against him. However, because man is created in the image of God, he is not only free to choose, he must also bear the eternal consequences of his own decision. The way to God is still clear. Everyone who converts to Jesus Christ today receives forgiveness of their sins and eternal life. The Bible states in John 3:36, "He that believeth on the Son hath everlasting life, and he that believeth not the Son shall not see life, but the wrath of God abideth on him." So this is the end of my talk, and thank you for following this fast-paced talk, and I hope I could get to you a lot of new points to think about, and looking forward now to discuss with you. Thank you.
Thank you, Markus, for that stimulating and thought-provoking presentation. And so at this point, we want to open the question and answer time. So if there are questions that have come to your mind during the presentation, please type these into the chat box on your screen. We'll start addressing these questions. Let me start with this one. And I think the answer is pretty clear. The question is, in your presentation, several scientists said that there's no direct causality linked between CO2 levels and temperature. Would you agree with that? I think that it's somewhat nuanced, because there is a connection, but it's not what the most climate scientists would agree with.
Yeah, actually, we cannot say that there is no connection. So CO2 certainly has an effect on temperature, and Bill Hepper has made a very good contribution here with a publication, and he has shown that with doubling the CO2 concentration, the temperature increase is about 0.7 degrees. This is not much, so no catastrophe looming, but clearly we have some effect here. So we cannot say there is no effect. But the point I was making here is that we are not need to be worried about this. And of course, there is the discussion, and there are some people who say that there is no effect at all. I think that's scientifically not correct to state this. We have to be on a scientific ground and to look at the data, and we see there is some effect, of course, but we cannot influence much of the climate, basically. So that's what my message is. And but nevertheless, it's true. There are some scientists which say, or people which say that we have basically no influence. So we have to be careful about how we express things here, and not to exaggerate, and to stay on the truth here.
Okay. There's another question that has come in, and that is, let me try to get it up on my screen here. Having a little trouble with my mouse. Well, the question is, how has the data for what the actual temperature has been over the last 2,000 years obtained? What's the primary? Has it been possible to estimate the actual temperature over the last 2,000 years?
Yeah. For example, what I showed was the curve from Professor Büngten, and they used several, as I said, proxy data. And this is, for example, by tree rings. So they have to look at the width of the rings and to see how the growth of the trees was. But this is a very delicate thing to do. You can easily not have the right tree rings here, and that's why this publication is, I think, very important, which he made, because in this publication he made very clear how he exactly, and this would be very tedious to explain now, how exactly he came to the selection of this data. And this was not his own decision, but in the group, as I said, of the several different scientists. And there are more means, more proxies. For example, you can also use oxygen isotopes. And so there are a couple of, this is just two examples, a couple of indirect measurements you can use. But the problem is, with all these kind of indirect measurements, you have to be sure that they all that they have not a systematic error within, and that they all match really. And that's a problem. If you mix up too many methods, you get exactly what the IPCC gets. You get a flat curve, and you cannot see what the real data are. So you have to, as Büngten did, he concentrated on tree rings and some other indicators in order to make sure that he did not mix up different methods, which then basically equal out the measurement effects.
Okay. Here's another question. Was the medieval warm period, which began about 800 AD, a time that was warmer than today?
As you could see from the data, it wasn't warmer than today, almost as warm as today. Today we are, in fact, a little bit warmer. That's true. And that's what I showed. Could you see in the curve? I had this brown or curve, and this was showing a little bit higher temperature than in the medieval warm period. So that's what I would think is true. So we have a small effect here. We cannot negate, and I would, but we are very similar to the medieval warm period.
Just my own comment, wasn't that the time that most of these large cathedrals in Europe were built?
Yeah, exactly. That's a good point, John. People are not thinking typically what happens if it gets warm. If we look in the history, warm times were always times, especially in Europe, the best times, because people were not hungry. Everything was good for plants, and there were typically no wars at these times. And so everything was growing. Culture, religion, science, everything was blooming. But then in the times when temperature was much lower, in the ice ages, of course, then people got hungry and there was not enough food, and then the wars began. So we should be worried about the planet becoming too cold and not too warm. That's what the history tells us. Exactly what you're saying, John.
Yeah, the little ice age around 1600. That was the time when these plagues ravaged much of Europe, and there was lots of starvation.
Yeah.
Let's look at. Here's a question. Um, let's see here. Do you agree that there was a post-flood glacial advance or ice age? If so, is it possible that global climate might be moving toward equilibrium from that disturbance, that climate disturbance?
Yeah, I definitely have to say yes. So that I think it's very clear that we have an ice age as a consequence of the global flood, because during the global flood there was a warming of the oceans and there was a lot of vapor in the atmosphere, and then you have the ash from the volcanoes, and then this means you have a lot of precipitation and even snow in the northern regions. And so as a consequence of this high precipitation and also cooling in certain parts of the globe, there was an ice age. And yes, definitely, we are now in a phase where I think we are still recovering. Also, I think we are not far from equilibrium, but I think yes, one could say this. Yeah.
Another question I think you've probably answered pretty well. Would you agree that we could have a much greater CO2 concentration without any negative effects for humanity?
Yes, I think so. Because temperature, if you double, for example, from 400 to 800 ppm, the temperature should rise about 0.7 degrees or something like this. We don't know exactly, because there are some, as I explained, effects which are not yet understood, the clouds and so on. But I don't see major negative effects. In contrary, getting a warmer climate, as we have seen in the past, has positive effects. So, yeah.
One additional question. This person has seen some scientists are saying that the link between CO2 and temperature seems to go the other way. That is, temperature first rises, then the CO2 concentration rises.
Mm-hmm.
Is that valid?
I mean, there is this ice core measurements in Antarctica, and yes, these ice core measurements, they show that the temperature is not following the CO2, but it's the other way around. So one could argue from these measurements that there is no correlation at all. But I would be careful not to over-exaggerate this, because if you take a global mean, then I think we can see that the CO2 has an effect. But there are some time lags or things we don't understand why the system is reacting so differently. Antarctica is also not the same like it's on the southern part of our globe, and we are on the northern part. So I'm not sure. I don't know actually why this is the case, but I don't think we can say that there is in the long term no correlation. Of course, the correlation is pretty bad. If you want to have a really good correlation coefficient, this is not the case. You can plot the temperature and the CO2 on the northern hemisphere. You can see, yeah, okay, temperature is increasing, CO2 is increasing, but it's not a really good correlation. But nevertheless, we need to take into account that the temperature is not following linearly. We have a nonlinear system here, and nonlinear systems are not behaving like we usually would like to think. So we have to be careful if we look at these curves, and then to say there is no correlation at all, I would be careful. So, but what we can clearly say is that from the calculations, from what the CO2 has from the atmosphere, from the absorption from the infrared, we can clearly say that the effects are pretty small. So that's what I would stay at, without going into too much detail about this time lags and such things, which are there and which show that we probably don't understand the system yet fully. But I don't think this is a major point to make.
Okay. Yet another question. Do many secular scientists agree that at some time in the past there was a 16 times higher CO2 level? Is that generally accepted by the secular scientific community?
Oh yeah, definitely. I mean, you just have to look at the different publications. Of course, there's a range of factors. I have seen publications with a factor of maybe 5 to 10, others in more than 20, 25. So somewhere in between, I think the truth lies. So I don't think we can nail it down so exactly in the past. I've seen recent publications which are more seem to be more accurate, but I think it's fair to say that we are factor 15 have been 15 higher than the past. Anyway, if it's factor 10 or 15 or whatever, we are talking here about factors which are extremely
way beyond
higher.
what we're talking about, what people are expressing concern about today in the discussions. Yeah.
Right. So.
All right. This question has to do about the dynamics of the sun. It's why is the impact of the sun and activity from the sun not being taken into account in these climate models?
Well, I think that the problem with the sun is that it's still not fully understood. I mean, there a couple of years ago, people thought that maybe the solar wind could have had an impact because, there's a problem, how do clouds form? And for clouds to form, you have to have a condensation of water vapor, and then you have to condensation particles somehow, and the solar wind could cause this because you have this shower of particles, and this makes this nuclei where the clouds could condense. But this could not have been convincingly shown to have this major impact than we thought. I think there may be other effects which we don't know yet, but as it stands now, I think we cannot, from the scientific point of view, from the current publications, clearly say that the variations in solar output have a major impact. Of course, the sun is a main impact regarding the radiation coming here to Earth, but it's more of not a question how much the variation is in the what arrives here, basically, but we have other factors which are more important, namely how much of this radiation is retained. And that's what the CO2 is doing, and other climate gases. And
let me just follow up on that question. What do you think is responsible for this change from like the Roman warm period, and then a cooler period, and then the medieval warm period, and then the little ice age? What do you think, what was the main factor driving that oscillation in global temperature?
Yeah, as I said in my talk, I think Professor Büngten is right. I think it's what we have here is volcanoes are the main reason in the past why we had temperature drops and these ice ages, and the warm periods are just recovery phases of these ice ages. So we have to. So it's not, our focus should not be on the warm phases, but on the cold phases, how they are coming about. And so we are coming out of a cold phase from an ice age. So from a physical point of view, as a physicist, it's clear to me that a system which has some oscillation, when we are coming now out of a cold phase, that of course temperature is rising now and maybe even shooting over the average. But as I said before, still humans have some impact. So we add a little bit to this one. But basically we have what we see is I would say, as a oscillating system here.
Okay, this next question has to do with the status of the ozone layer. Is there still a hole in the ozone layer? If so, is that a valid concern, or is that also part of the political agenda of climate change?
As far as I know, the ozone hole basically is not a great issue anymore. I remember when in Australia, when we had this news and people got sunburned and everything. And so they in fact, we had this, but I don't think this is a major point to be made right now anymore. I'm not sure if it's fully understood why the hole has basically disappeared, and not completely, but so I cannot comment on this one. What the current what is scientifically happened here with the ozone, but my estimation is that this is not something which is a major concern here.
Okay. I think we have covered well, there's one here about that. The question is, how long have we had thermometers? Is it less than 300 years? If so, when they talk about the hottest on record, the record really isn't that long, is it?
Right.
You were talking about these proxies, ways of estimating the temperature many centuries ago, before the thermometer was invented.
Right. I mean, that's a very valid point, of course. We can measure only like 150, 200 years, I would say, reasonable temperature. Yeah, in fact, if you look at the different publications on the reconstructions of the temperature in the past, there are a lot of differences. And that's why I picked Professor Büngten's publication, which is a quite recent one. And he really was going into the heart of the discussion. How can we get more close to the real temperature behavior in the past? So I would say maybe in the last 20, 30, 50, 40, 50 years, we could not really say. I think we are getting closer, but it's a really difficult subject to reconstruct the temperature in the past. And so we have to be careful. But it's clear from what, as I said in my presentation, what we cannot do is draw a flat curve like the IPCC does and get the impression to the politicians and to the people out there that there has been no change.
Yes, that's a very important point. Here's another question that a good question. Does the increase in plant life mitigate or reduce the level of CO2 in the atmosphere?
Increase in plant life? I don't quite understand.
If you're saying that CO2, increased levels of CO2 in the atmosphere cause these plants to thrive, to grow better.
Oh, okay, yeah.
And so when that happens, does that reduce somewhat the amount of CO2 in the atmosphere? Does that and I think the answer is yes. That CO2.
Yeah, of course, the plants absorb it, and yes, of course, this is a system which is, we have not a system which is out of control. You see, you have negative feedbacks built herein, and that's one of them. That's also typical in chemistry. You have this often, Le Chatelier's principle, and this basically says that systems in nature, they're typically not unstable, but what happens is there are a lot of damping factors typically, and that's one of them.
Right. So the way to make a system stable is to have negative feedback, and this is an example of that. And it results in stability in the system.
Right.
Okay, let me just see if there are any any later questions that have come in. So let me just ask a final question here about how in Germany, how strong is do you see trends that people are really serious about green religion, that people are that worship of the earth is something that you see much evidence of that within the German society?
Well, this worship, of course, is not like, they bend before some statues or something, but you can see this from the point of the fact that people are so concerned, and their main concern is here in Germany, their economic well-being, nature, all these outer factors. But people are completely diverting from God. So it's most people are not concerned about the future, the eternity, but they are only concerned about their life right now. Maybe things which are really not so important, but that's the kind of religion they are following, and they get entrenched into this without even knowing that they are religious. So I wouldn't say that the Germans are religious in terms of they run around with green banners. There are some kinds of people, but I know a lot of people which we are very skeptic about this. But in the end, it turns out that people are still only focusing on this life and on nature. Here we have a very nice nature in Germany. We have a lot of green forests, and as you said in the beginning, I'm living near the Alps, and this is very, very nice. So people want to let everything stays nice as it is right now, and so they are naturally concerned. And the problem is the media all the time. You hear nothing else than weather is becoming more extreme, and they show in the news all the time what happens not only in Germany but all around in the world, and people are concerned. So maybe this could happen also here in Germany. But I have also want to say one thing. I noticed in recent times that people are less worried now maybe about climate. They are more worried about the war, which is pretty near to us now here in Europe. So this is somehow, there's a lot of movement right now here, because the Green Party, they have lost a lot of people because the Germans begin to realize that not the climate is maybe the main problem, which I say now for more than 10 years, but it's other things. And if the war is before your doors, basically, then you have to become more worried about this one. And I think this is something which I think is good. I don't think war is good, but I think it's good to be more realistic. But nevertheless, I don't think this is going to go away so easily, because you have this propaganda going on. And I get invited, give a lot of talks on this subject. And very often I'm asked to give a talk about climate catastrophe or something like this, because this is still the main thing for many people to be worried about.
Well, thank you for addressing all of these issues and hopefully clarifying many important points. So I'm hoping that people that came into the discussion with some concern about the future of the climate feel relieved to realize that the evidence is really not substantial, that we're facing a climate collapse. So we really appreciate your taking time, Markus, and may God encourage you and bless you in your ministry there in Germany. And let me end with advertising our talk for next month. The speaker is going to be one of the premier creation scientists of this generation, Dr. Jonathan Safarty. His original training was in physical chemistry. He's got a PhD in physical chemistry, and he's going to be addressing the very important topic of the origin of life. So, and that's going to be on Wednesday, the 13th of November at this same time, 9 p.m. Eastern time. So tune in for another stimulating talk. And so Markus, thank you. Thank you again. May God bless you. And may everybody leave encouraged tonight. Thank you.
Thank you also.